Good evening. My name is Asif. I take care of recruitment here. Uh, thanks, thanks for coming. I know how tough it is, like on a weekday to come in the evening. Thanks for coming. Right. I think usually we start by asking questions like, uh, for how many it's the first time for the Geek Night, right? And others have been, right. So. I mean, this is a community event, right? Every month, third Thursday, we make sure that no, we pick up a topic, we bring in speakers, and make sure that no, gives an opportunity for us to interact, learn, and network, right? We have been trying to bring in people from outside and also internal to showcase on any of the topics and get interacted, right? And the other thing which why we thought is we want you people as audience who are coming in to socialize this event, right? So this would help the ecosystem of Coimbatore itself to get better and stronger. An opportunity which will open for people to get network, know things. I think that's need of the hour for Coimbatore, because whatever conferences happen in Coimbatore, so there is a limited crowd which comes in and there is a limited amount of interaction happens, and most of the people who be a part of as a speaker or a jury, they just come up with a concern saying that, okay, so what's going to be the ecosystem and how it looks very weak, and how are we going to make it better, right? So ThoughtWorks had that thought very earlier itself. That's why we, as an organization, every region we do various community events. So in Coimbatore, this is one which we do focusing on devs. So that's just in requests, so that like as an audience, as an techie, make some interest, try to socialize this, talk to your friends and show interest on any topics that you want to come and present or talk. Very well will be able to host you, right? Okay, so that's what I wanted to. So we have today Sakthivel and Muhil, who's gonna talk about GraphQL. So over to them. Thanks.
Yosef, okay, so how many of you are students? Mostly, okay. So how many of you are software engineers? Okay, cool. Okay, so today in this session we'll get introduced to GraphQL. I'm not sure if any of you have heard about what GraphQL is. Anyone had heard about GraphQL? Okay, so the agenda, the plan for today is to get an understanding of how GraphQL, is helping us out in the sense like when we compare it with REST. I'm not sure whether you might be familiar with the word REST APIs. So we'll try to touch upon it and how GraphQL, solves many problems that REST is basically, having some limitations upon. And then we'll try to cover upon a few jargons in GraphQL. So jargons, when I say like what are the things that are required for setting up and running in GraphQL, and we'll try with we'll do a demo with GitHub APIs. So I'm pretty sure that many of you have heard about GitHub, right? How many of you have account in GitHub? Probably everyone is aware of it, right? So that's good. So so once that is done, we'll compare GitHub APIs with REST APIs as well as GraphQL APIs, how it helps us to query results, and we'll cover up on tool chains surrounding GraphQL. So followed by a workshop which will be taken up by my colleague. Yeah, so we'll get on with it. Little introduction from my end. So I'm Sakthivel. So I'm working as a senior consultant in ThoughtWorks. And the second half of the GeekNight session will be taken up by Muhil. So he's working as a consultant at ThoughtWorks. Yep. So REST. So what is REST? Anyone have any idea? probably so software engineers here would have write a lot of APIs. So REST basically is a specification which was developed around 2000. So it provides us with a specification of how two systems should communicate with each other through HTTP protocol. So basically, if we wanted to request some resources from a database, if one service wants to communicate with the other service, we usually go via this specification, that is REST. So if we wanted to fetch from fetch some data, we use get queries. Probably if we wanted to fetch a particular record, we use you pass parameters and we probably get the record. And usually post is used for inserting, put for update. So probably everyone is aware of it. And so these get, post, put are called verbs, and they actually specify or differentiate what operation you're trying to do when you hit a server. Okay, so uh, so going on with the REST, right? Do you guys faced any challenges when working with REST? Anything that comes up to your mind? Probably, server team will be writing up some services, and we'll be having client team doing all the UI related work, and probably you'll be getting the API data and you'll be fetching resources through API. So any challenges that you could think of? Handling exceptions, okay. Okay, so the API keeps on changing, and the document may not be updated, it will be left around, okay. Okay, so versioning is another problem, okay. Okay, so these are all some of the limitations. Again, like so we will be more focused on the following limitation: getting more data from an API than what we require. Say I have a client page and I have some particular details that I need, but unfortunately the endpoint provides more data than what I'm supposed to use. So in those cases, there is no way that you could ignore all the other data, but you need to use the endpoint for your particular need. Basically, there will be a lot of data, and you won't be able to filter out the extra data that comes up with every request. So in this case, right, so this is an example API, Get API. So GitHub, Microsoft, if you see here, Microsoft is the organization, and under the Microsoft organization, we have multiple projects. So basically what I'm doing is like I'm doing a get call, I'm getting result. If you could see here, the only thing which I'm interested is like the description and the name of the repository. But all the other thing I'm not interested in, I don't want, but do I have a choice? No, I don't have a choice, but I need to download the entire data to making any process. So this is overfetching. And when you talk about the data, right? So particularly I need team related information. Okay, so I have the projects and I need team related information. So what I usually do is like I take up the team URL and basically I do another query, if I'm not wrong. So there will be waterfall of requests. So the first request will give you the URL, and the second request will go to the server and it will fetch some other data and do some processing. And again, like if you are requiring more data from that response, basically you do another API fetch basically. So 3 API requests for some part of the data. Okay, so it actually increases round trip, and also the data which you are downloading is not necessary at most of the time. Okay, so these are some of the problems with REST APIs. So overfetching and underfetching is one of the important problems when we go for mobile application development, because most often we'll be having the same REST APIs exposed to different clients. I can have a mobile, I can have a desktop UI, so both will be having the same set of endpoints, and oftentimes a lot of data will not be necessary in case of client. So this is one of the problem. And if you take an example here, so the UI which we have is to the right is the desktop UI, and the mobile view which is to the left, to the left. So in the desktop UI, if you see like so for this particular product, we have additional information specified. Okay, if you see over here, we don't have that related data. And again, like so there is no extra EMI related information, but the data that is shown in the mobile UI is totally different. So if you are having a single API server or endpoint, then it is kind of a problem where like the extra data might get downloaded in the mobile view itself. This is often a problem when you are working on a low bandwidth. Say, for example, I am having 2G connection and the data which I download is very critical. I don't want to download any extra data. So in those kind of scenario, if you have a single server serving the endpoints, then it might be a problem. Okay. So what is the solution for this problem? You go for multiple projects, maintain different set of endpoints for client maybe, for server maybe, wherein you will be giving only the data required for client, and for server or the the desktop UI, you will be giving some extra information. That is one problem. And again, like it makes us to maintain two different repositories basically, and the data changes comes in, new endpoints, lot of issue comes up. So these are again like the other limitations. Say if I'm getting a rapid UI changes, so a lot of UI change requests, then some field may be available in the endpoint, or I need to make some changes in the endpoint, or for some particular data, I need to create a new endpoint. Basically, we need to create new endpoints, and there is no API documentation as one of us mentioned, and ultimately one important thing is like there is no enforcement of specification. Say we saw here, right? So in get, if I am allowed to do some posting through a body, yes, I am allowed. In case of post, I can update any data. So in case of delete, even if I'm not deleting any resource, I can make some changes in the server to make it update or insert. So there is no restriction, or there is no enforcement when you talk about the specification. So coming to GraphQL, right? So how GraphQL solves these problems? So when we talk about GraphQL, right? So GraphQL is a query language for API. So before we continue this, right, I wanted to make one thing clear. So yesterday I was having a discussion with my colleague and I was talking about GraphQL. So he mentioned that he was sure that GraphQL is a database concept. Okay, so I want to make something clear. GraphQL is not a database concept. It is a query language for your API. So basically you can write queries similar to SQL and you can fetch response based on the query that you're writing. It's a query language, okay? And also like it has a server runtime. It usually passes this query and based on the query information or the field that you are providing, it fetches you the data, okay? So declarative data fetching. So you declare what you require and you receive what you exactly need. Okay, so this actually solves most of the problems that REST has. So GraphQL was introduced by Facebook around 2015. So it was made public by 2015. So when we think about Facebook, right? So how the data modeling is done in Facebook? Say you have users, you have friends who create posts, etc., etc. So you like those posts. So basically, we can think of Facebook data in the form of a graph data structure. Okay, so everyone is aware of what graph data structure is, right? So we have nodes, so the nodes have relationship, and that's how we actually traverse through the graph. Okay, so if we see this image, right? So we have user A, user B. Everyone is interlinked because they are friends. For user A, we have three: user C, user B, user D friends, and like user E has created some posts, and basically different people, different users like it. So if I wanted to query the posts liked by the friends of user B, okay, so I'm a user A, I logged in and I wanted to fetch the posts liked by user B. How do I do it via REST? Any thoughts? Or should I rephrase the question? Any questions? So I'm user A, okay, so I wanted to fetch the posts of user E. The only relation I'm having is user B. I mean, like I wanted to fetch the post of one of my friends, one of my friend of my friends, basically. So how do you go about this in REST? So basically what I'll do is like I will have an ID, user A. I will post a request, or I will post a GET request to the API, and I'll get the list of friends, and from there I'll get the user IDs, basically the unique identifier, and I'll again post it to the server and basically get all the friends related to user B, and basically I'll get the post. So how many API calls are we making? Like 3 API calls. So that is one of the problem that Facebook tried to solve. I don't want to make multiple API calls to fetch some data which is already linked in some way. Okay, so that was the basis, that was the idea behind GraphQL, writing a query language for a API. Okay, any questions so far? So the history behind GraphQL is like internally it was, yeah. So it doesn't implement database structure internally, but it is one of the best practice to think your business domain in the form of graph. So that is what Facebook actually mentioned. Like it doesn't necessarily need that your business domain needs to be in graph, but it is always a best practice to think in the graph perspective. So it will be easier for you to query any data in your database. Okay. Does it answer your question? Thank you. Yeah. Thanks, Mohit. So this is the history. I mean, like, so it started around 2012. So it was internally used by Facebook, and it went on to be publicly released around 2015, and then it was widely adopted. And around 2018, GraphQL Foundation was formed. Uh, and we'll get into the schema types. To get started with GraphQL, right, we need a few things in place before we can expose the existing database or existing data through a GraphQL API endpoint. Okay. So the first thing we need is schema. So we'll be writing some schema. So when we talk about schema, right? So what is a database schema? So you might have definitely heard about schema when you're working with the database, right? So what is a schema? Basically you define what your data is actually. So that is exactly the same meaning. It has the same meaning here. So you define or you provide a blueprint for the data that is already existing via a few types. So GraphQL has its own type system. Let's say like every languages has its own int, float, flavor, etc. So similarly GraphQL has its own type system. So int, float, string, boolean, and id are some of the types. And when you talk about ID, right, ID is the type that is used to specify a unique identifier in a particular collection, just at the bottom. Okay. And we have type modifiers. So type modifiers, you can say it has a kind of a rule wherein you specify for a particular field, right, what is the data that you are expecting in that field. The first being like it's a nullable string. So when you talk about string, right, it is a nullable string wherein it can accept any null data for that particular field. And if you wanted to make it a mandatory one, a non-nullable one, you provide an exclamation mark to the end of string. Okay. And if you wanted to get a collection of string or a collection of list, or sorry, collection of integer, collection of boolean, you provide it with the square bracket, similar to the array syntax in JavaScript, if anyone is familiar. And if I wanted to make the list of strings mandatory or a required one, I add exclamation at the end of the string. And this particular case is something where you want the list to be mandatory and the objects inside the list should also be mandatory. So in this case, use the systems. So I would recommend to go through this cheat sheet wherein you will get to understand the other types involved in GraphQL. So first thing we require is schema. We will be setting up a schema. So say for example, I have a database with me. Okay, movie database probably. So I wanted to define some types in that database. Okay, so what I do is like I use this particular syntax. I define type, and this is the name of the object type, and probably I'll go and define my fields. Okay, ID, title, year, and box office are the fields for that particular movie object. Okay, so the box office at the bottom will have a collection of box offices. So box office in turn is another type wherein it defines movie ID. It primarily, it actually has a relationship with the movie type and region and collection. Anyone having any doubt? Any questions? Yeah. Yeah, we can have key value pairs, yes. It, yeah, go ahead, complete. Yeah. Yeah, so database structure and the schema structure doesn't need to be, exactly matching. So you can define your own schema, and based on that schema, you can, probably map the database values to that schema. So that is actually possible. So what you are trying to do is like you're kind of defining a mapper wherein the database structure will be different and the schema will be different. So the schema will be exposed to the clients. Okay, so the database structure will remain there, but the schema is the one that will be exposed to the clients. There is a mapping, yes, involved. Yeah. And this is the schema that you will be defining. And going to the query part, this is how we'll actually call it from the service or the client. So what you will do is like you will define a query, and you will say what is the function that you need to invoke, and you will specify what are all the data that I need. So in this case, if you see, like I am not querying for year, I query only for ID and title. This is something that will be written in the client end so that the client know what they are trying to get, and even if title is not relevant to me anymore, I can just remove the title and I won't be getting the title via APIs. Okay, so this is the basic structure. We'll get into how we actually use queries in the future slides. Okay, any doubts, any questions? Yeah. Uh, SQL queries, particularly it queries the database. Okay, so in the case of API, in the case of GraphQL, it queries the API. So basically you will be having 5 different APIs. 5 different APIs will be querying different set of datas. But on a consolidation basis, like if you wanted to have some data in a combination with this 5 API endpoints, you can basically write your own queries and you can implement that so that based on your requirement, you can fetch the data. Okay, so the syntax around the syntax for query is somewhat similar to JavaScript object notation, wherein it's the key and you don't need to specify any commas and there is no value involved. Okay. Yeah. So this is how actually we'll be posting the queries to the API. Yeah. Yes. So we will eventually get to that. So this is what we define in the schema, and this is will be exposed to client. So where we'll connect the database, we'll get to the particular slide. So it's we are going to cover that. Okay. So to add it, so this is how you will be querying. So what I'm doing is like I am passing this query, and basically I will be getting only the data that I require. No overfetching or no underfetching. Okay. So the first thing we were discussing about writing the schema to basically map your database structure with the schema that will be exposed to the client. So the second thing we wanted to understand is the root types. So basically we have 3 different root types in GraphQL. So one is query that we saw earlier, and the next is mutation. So mutation is nothing but a change. So if we wanted to do some updates, insert or delete, that is particularly if you wanted to do some state changes, you go for mutation. Any doubts? Okay, basically it's it's similar to post, put, delete that you use in REST, right? So that is what it matches to a mutation. And subscription is interesting because when you do a subscription, you're basically listening for any changes that happens in the database, so that an active connection will be there in the client, and if any changes happens, then basically it updates in real time. Yeah, it's socketing, yes. Okay. So this is how you define a query, and this is how you define a mutation. When you wanted to do some mutation queries, you specific the mutation keyword and you use the name, and basically you pass in the particular fields. And this is the return type that you will be getting after updating, deleting, or inserting. So these are the fields, the title and year you will be receiving as a response. Okay. So this is the second one. Like the third one which we are going to say is resolvers. So that is what it will answer your question. So resolvers are nothing but a function that implements a GraphQL field. So basically what I'll do is like I'll define what are all the queries that I'm going to expose, and also the list of mutations that I want to expose. Under queries, if you see here, I have defined get movies and hello. Okay, so basically hello returns hello world. This is what you saw here in the hello. And get movies ideally returns all the movies related information. GraphQL server runtime internally filters out the field that only required for that you have requested. And this is where the mutation comes in. uh, Mutation, the resolvers will have four arguments in place. The first being the root type or the object, the second being the args. So the args are the parameters that you pass from the front end, and the context will have any authentication OAuth token related information that will be passed on to every resolvers. And to answer your question, this is where we connect to any APIs or any databases that we wanted to fetch. And we fetch it from the database, and basically we do some sort of filtering over here, and we'll send it to the front end. So the resolvers are the places where we'll have all the API related information, or third party APIs, database, any connection that we wanted to make. That is, the resolvers are the place to put those things in. Does it answer, right? So you will get to understand more when you see a practical example, which will be happening in the next session. So yeah. So any questions, or can we move? Yeah. Mm-hmm. So actually, so to answer your question, like if I need something, if I'm going to do a third-party implementation, then I'm the one who is developing, and I know what exactly what that I need. So I won't be going for a database implementation when I'm writing or expecting some data from the third-party API. And the third-party API, which in turn returns the data, should match my schema. So that is where I will write my details. Even if you wanted to have a database query and REST API, you can have two different resolvers, and you know what exactly that's happening, so that it will be easier for you. Yeah. Okay. Yeah. So a quick difference between like REST and GraphQL. So for REST, you have get, post, put, patch, and delete. But in case of GraphQL, we have only two methods: post and get. Okay. So out of these two methods, post is the only method that we'll be using for sending all our queries. In the previous slides, you saw query and mutation, right? Those things will be part of the payload that you send to the server in the form of string. So that will be passed in the GraphQL runtime, and basically it will filter out only the data that it requires. And get in this GraphQL get is only used for getting the schema. So you have defined the schema, and the client wants to understand what schema that is defined. You use this get call for getting the schema that is defined. And the API documentation comes out of box. You don't need to specify anything explicitly. You'll be able to go through the documentation, and based on that you can make any queries that you need. And these are all the action types. So as I mentioned earlier, query, mutation, subscription are the action types for GraphQL. And REST supports only HTTP protocol, whereas GraphQL supports any protocol, and it can be implemented in any languages as well. So GraphQL is not particular to any language. We have packages for Java, Python, Ruby, etc. That is part of the community. Okay. Sorry. PHP, I'm not sure. Maybe there is something for PHP as well. Need to check. Yeah. Okay, so we covered a few limitations with REST, and then we also covered like what is GraphQL and schema. So for getting started with GraphQL, the three things which are very much important is schema. You define your schema, and then you define your root types. In this case, query mutation or subscription, and then you go for the resolvers. So resolvers are the part wherein it will make some communication with the API or database and fetches you the data. Basically, these three things work together, and you can fetch any data through GraphQL APIs. Okay. Any questions so far? It can call. So that is where the first argument helps us. So in the object argument which is passed to the resolver, right? It can have multiple resolvers getting called, and based on that, it can also consolidate data and send back. Okay.
Where, suppose we have an object, right? It has multiple relationship. So in that case, it will be automatically GraphQL will trigger the nested resolvers, and it will get the data for us.
So that is something Muhil will be covering as part of the. So we'll have it in the next piece. Yeah. So right now, I like to go through a demo of how REST endpoint work and GraphQL endpoint work. So GitHub recently migrated their APIs completely from REST to GraphQL. So V3 is the version of GitHub which is completely exposed via REST, and V4 is the version that is completely exposed via GraphQL. So before we get into the demo, right? Previously I told like we need to model our business in terms of graph. So that is what Facebook actually did. And when you think about GitHub, right? So if you could model it in a graph data structure, so how would you model the data? Folks, okay. So basically I have an organization, and then inside the organization I have different projects, and for each project I'll be having contributors, issues, and each issues will be having comments. So we can picturize it in a form of a graph. So if we picturize it, so this is how it will look like. So under organization, if you have an organization, you will be able to access all the repositories, and for each repositories, multiple issues will be there, and for each issue, we'll be having multiple comments. So this is how it has been modeled in V4 version of the GraphQL. So I have one example. So what I'm doing is like I'm actually fetching all the repositories that is open repositories from Facebook, and what I wanted to do is like I wanted to list all the issues of one particular project basically, and from those issues I wanted to see what the comments are. Okay, so when I click on this first one, right, so it shows me what are all the issues for this particular project, and if I click on one particular issue, I will be able to see all the comments that involved. So this is actually just a basic so how will you achieve this in REST? Exactly. So if you see the API, right, so the first being like I'm getting the list of repositories. So what happens is like I'm getting a list of repositories, but I am getting a lot of data that is not relevant to me. So the only thing which I am showing it in the UI is the name and the particular language for that repository, but I don't have any choice, but I need to download all these things. And next, once I get all the repository related information, as you mentioned, like I'll be passing into the issues REST endpoint basically, and from there I'll be getting a lot of data. Again, I don't want all these things. If you see over here, I need only the status and the title of an issue, but I don't have an again choice. So that goes the same for comments as well. So a lot of data are getting downloaded without so I don't want all those extra data, but I don't have any choice but to download them and utilize them. Um So how do we do the same in GraphQL? So for every GraphQL, when you write a project, right? So we have this GraphQL Explorer, wherein you can execute your queries and see how it actually responds. And that is the Explorer where you will find the documentation as well. So it comes out of the box and it is available by default. So similarly, we have an API Explorer for GitHub. So this is for the, as I mentioned, like V4 is completely done in GraphQL. So if I wanted to do the same thing in GraphQL, I'll start with my organization. Okay, so I'll query the organization. So basically it has intelligence based on the available fields that are already there, and I can pass parameters. This is how I'll be passing a parameter. So I want the titles of all the projects that is available in Facebook organization. So before I get into that, like I'll be fetching the organization name, and we have multiple fields for the organization. Right now I'm only interested in the name part, and if I wanted to go for all the list of projects available in this particular organization, remember the node edge relationship that I showed, right? I'll go for the repositories, and basically repositories are all nodes. So it is not mandatory to design your system in such a way that it matches the graph data structure, but it is an advisable or a best practice that is given by the GraphQL team. So I will actually query the list of nodes. So what I'm doing here is like I'm getting all the repositories for this particular organization Facebook, and the fields that I require is name for that project and the name with owner. So if I execute this, I will be getting an error basically. The reason why I'm getting an error is like I didn't pass the pagination information. I don't want to extract all the repositories. Maybe there will be some 1,000 or 2,000 records, so I don't need to get everything in a single fetch. So I need to basically pass in an argument stating that I need only the first 10 repositories. So this form of enforcing comes with GraphQL. In case of REST, right? So we need to explicitly define all those things. So what I'm getting here is like I'm getting the list of the first 10 repositories in Facebook. And the next thing I wanted to do is like I wanted to get all the issues for this repository. So basically for that, I don't need comma here. I go for issues. So issues, and in turn, again, it is a node. Okay, so you need to go for nodes. And I'll go fetch all the titles, and the same things goes here. I don't want all the issues to be listed. I need only the first 5 maybe. And when I execute it, I'll be able to get all the issues for that particular. So for the first repository, I'm basically getting 5 issues that are listed, and I'm not getting all the fields. I'm requesting only the title. And we can again go one level deep and request for comments. So for the sake of visibility, I'm filtering everything to one. So if you see over here, I have a repository, the first repository which is filtered for me, and the first issue with the title filtered for me. And again, so for that particular issue, I have comments filtered out for me. So in the case of REST API, I need to make multiple API calls for getting some particular data. And in case of GraphQL, I can do it with a single API query. Okay. Any questions so far? Yeah, so that is the relationship that they are trying to, so the GitHub, implemented the graph relationship for their business model. basically the relationship how it handles here is like the repository will be having list of issues basically, and the issues will be having again a list of comments. So when you picturize the graph that I showed here, it makes more sense for us to understand the data that we receive. Definitely there is an hierarchy because only repositories can have issues, and again like only issues can have comments. Basically other model can also have different set of data basically, but in case of this result or this model, we definitely have an hierarchy. Okay. So yeah, so this is the documentation that I was actually talking about. Like when you go and click on the first thing, we usually have a documentation like organization list out what are all the parameters that it can accept. So these are all the arguments that I gave as a login. And when you click on the organization, you will have a list of what are all the things that are it is actually implementing. And the particular thing which we wanted to see is repositories. If you scroll over here, it will show all the properties that can be extracted out of this API. And when you go to the repositories part, you have the repositories, and these are all the information, and these are all the arguments that repositories support. And if you click on the repository connection, so connection is another concept, like it's not for today, maybe you guys can explore what a connection is, and it will makes more sense when you try to understand what a connection is. Like when I click on the repository connection, it shows us what are all the edges and nodes I can query. And if I click on the nodes, that is where my repository part comes in. So basically it goes on, the hierarchy goes on, and it will be easier for us for you to look into all the fields that are available and query basically based on the documentation that's provided. So this is no way different from a REST endpoint. So basically, for this to happen, there will be one specific endpoint that will be exposed. That will be /GraphQL, and it will be a post endpoint. All the queries that you see here will be sent as a string. So it will be JSON stringified, and it will be sent as a body in that post. And GraphQL runtime will basically parse it and do all the query for you, and it will return the response. It's just a post call, nothing more than that. Okay. Yes. 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 So basically, it provides some form of information, and you know what you're actually doing. So even if some changes that you're trying to make, like it makes sure that the client is more cleaner, and it will be easier for the client end as well.
And also this particular UI is there, right? It comes by default with the graphical server. For if you run a server on your local machine, right? This UI comes by default. We will see in the next session.
Yeah. Okay, so basically, what we're trying to do is like authorizing some data for some particular user. Authorization is the exactly right. So authorization is not, it's not advisable to the authorization part in the GraphQL. Basically, that needs to be handled in the business layer. So you have APIs, database connections that again resolvers try to resolve, right? So in those cases, in those places, it's better to do this authorization there. It doesn't provide any authorization out of box, but it's something that we need to uh, develop. Yes, schema. You can get down the schema. Yeah.
So like the client only decide what data needs to be fetched. So in case of there is no restriction from the graphical. Graphical gives whatever data it has. It's based on the client who wants, suppose mobile wants only list data, right? Then it fetches only list data. Web wants lot of data, lot of information, right? It can fetch a lot of information. There is no restriction from graphical server. Graphical server just say that this is that data I have. You can fetch whatever you want. Can just say.
Yes. 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 So exactly like so GraphQL can be said as a wrapper over REST APIs, but when you think about the processing time that is involved when the query needs to be passed, and again like there is some three APIs that needs to be fetched. But when you compare this with the three API calls that you need to make and basically download all the extra data that you don't require, basically this will actually a better choice.
So there's multiple factor why the graphical design. So one of the factor is that from your browser, right? For say single origin, you can call trigger like only five API calls. So think of the Facebook. Facebook, if you load a Facebook, right? How many API calls it goes in parallel. So then what they do, they have to deploy their API in some other origin. So that's one of the issue. And also like the load, suppose if you call 5 APIs in the browser, right? It drains your battery. Because it has IO call, it drains your battery. So if you make a single API call, let the server handle the pressure and it will give us the data.
Like in terms of like no low network connectivity or 2G, it makes more sense to have a single API call instead of having multiple. Yeah, thank you. So coming back, like GraphQL is not specific to any UI technology. So we have multiple packages for different languages basically, and there is again a misconception that the GraphQL is a database technology, which is not. And there is another misconception that it supports only JavaScript, but that is not the case because we have different packages for server libraries basically for different languages. And to answer your question, like we do have a PHP library. Yeah. So any framework has its own limitations. So does GraphQL. So when you implement GraphQL, you don't get the HTTP caching, default HTTP caching. So if any one of you not familiar with what HTTP caching is, like every endpoint, every request that you make, the browsers can cache that request. An image or a server request that's going on, it has the ability to cache it. But in terms of GraphQL, we need to do some extra work to make that happen. Basically, have the cache in some store, and that needs to be served to the client. And it is again exposed to certain arbitrary requests wherein you are exposing your endpoint to any query that might be coming up. We need to be very extra careful here because as you mentioned, like we are going to make 3 API calls or multiple API calls. We need to be very careful about what is the operation that we are going to. So it's up to us to decide the load factor precisely. And like again, like the third point, like being monitoring. So most of the systems, how monitoring is just like an HTTP REST endpoint will be exposed, probably a GET API. So for monitoring purposes, it will be hitting that endpoint and it will basically getting the response to make sure that the system is up and running. In case of GraphQL, we need to explicitly implement another REST point for this monitoring purpose. Okay, so yeah, like so as we discussed, like we are at the final stage. So as we discussed, like three important things For setting up and running with GraphQL, we define our schema. We set up our root types, query, mutation, subscription, and finally, we write our own resolver functions. So that's how you implement. So in the next session, probably you'll be seeing an implementation of how GraphQL is done by Muhil. Yeah, any other questions? Good, right? Thank you. Thank you all. So yeah, so we have refreshments, so guys can
Hi everyone, myself Mugil. I'm a full stack developer. So primarily I write APIs and design some UIs for living. So I think most of them you got what is graphical and its terminologies from the previous talk from Shakti. So in this session, right, what we're gonna do? We're gonna write a graphical server from scratch that will expose us Pokemon informations. Okay. So how many of them like Pokemons? I see only few hands. So if you don't know Pokemons, right, Pikachu will be very sad. So the person who don't know Pokemon, right? The Pokemon is a Cartoon Network it's a cartoon where in a fantasy world where Pokemon and human will live together and then they do a lot of adventurous stuff. So if you take in the Pokemon world, right, there are a lot of types of Pokemons. So there will be grass type Pokemon, then there are electric type Pokemon, and there will be fire type Pokemon, water type Pokemon. Like that, there are a lot of types of Pokemons. Each type will have like a number of Pokemons will be there. So what we're gonna do, like we're gonna expose this information in a graphical server. Why I took this example, right? In this example, I can build a graphical schema so that everyone able to understand it probably easily. Instead of taking some other technical stuff, right? It will be easy to understand. So let's say I take this graphic Pokemon example. So I got an open source dump where I got the entire Pokemon DB from a GitHub thing. So I got it in JSON. For the sake of time, what I did, right, I took the entire JSON, I converted it into a JavaScript file so that I can easily access in the code. In this workshop, I'm not focusing on any database thing because it consumes more time to develop a graphical server. So we'll see how the data will be there. So if you see here, right, this is a Pokemon DB which I downloaded from GitHub. So it has list of Pokemon types. This is the data. Suppose if you're writing an REST API, right, you will be exposing data in similar way. If you're writing if you have a DB, right, DB also will have the same kind of data. So here, right, we have an ID for a Pokemon type and then some name. So these are the normal fighting, flying type, poison type. These are the types of the Pokemon. So similarly, for each type, right, we'll have set of Pokemons. If you take a Bulbasaur, right, Bulbasaur has two types. It's a grass type and it's a poison. So if you see here, 4 will be a poison type and then here it's a grass type. This is a sample example of how the Pokemon and types have been linked. So similarly, similarly we have moves also. Now we don't need to concentrate on the moves. We just focus on the types and Pokemons. So suppose first of all, before writing graphical server, right, we should start with the type definition, the schema definition. So how do you define a schema for this structure? Let's start with this one. So here, right, type will be a Pokemon type. Here the Pokemon type is this one. It has ID and the name. So ID will be the attribute and this type of an ID. And the name will be a string. And it is required, right? So these are the basic information a Pokemon type has. Similarly, we want to define the type for Pokemon. If you see a Pokemon, right, Pokemon will have a name, which will be a string. This will be caps. And it will have an ID. ID will be ID type and required, and also types. If you see a types, right, types will be a array of Pokemon type. Now we got the relationship, right? So similarly, so in graphical, right, these we call these as object types. These are scalar types. Scalar types like a string, int, float, idea, scalar types. It's an object type. And also in graphical, you can assign a object type to an attribute. So in this case, right, I can define another object type like Pokemon base, which in turn will be an object type. In this case, we will have like these attributes. HP will be an int. These are the powers, like strengths of the Pokemons. Attack, how much attack it can take, how much defense it can take, how much special attack it can take. So these are the some of the attributes of the Pokemons. So attack, sorry, int, defense, then special attack, defense. Now we have defined our schema for Pokemon type and Pokemons. Okay. Now what we want to do? We want to actually what I plan to do, right? So I plan to our requirement is to develop an application like this, where we'll be listing all the Pokemon types here. Whenever I click this particular type, right, I should be able to fetch its Pokemons and its images. All those things I have to fetch it. That's our requirement. So in order to do that, right, first of all, I need to query the list of Pokemon types, right? So for that, I have a query type. So query is a root type. By default, comes from graphical. These are the object types which we have customly written. So here, right, query, I'm querying Pokemon types, okay, which will return array of Pokemon type. This is the schema I want to define. Okay, so this is done, right? And then what I do, I want to get the Pokemons, okay, based on the Pokemon type ID, which is an ID, which will return array of Pokemon. So here, right, this particular object type is used in this one, and this particular thing is used in here. This is the schema we want. So now we have defined the schema. Now what we want to do, we're going to create a graphical server in Node.js. The graphical server as I said earlier, right, it can be implemented on all the languages, but the base defines the same. We have to define the schema, and the implementation should be done properly in the Apollo server, graphical server.
So, any questions regarding the queries? Anyone?
Query part. So we have defined the object types. Okay, so this is structure of our data here. If you want to get the data, right, so get the data, we'll be using query as a type. It's a root type where we'll specify the Pokemon. This is the key. You can name it anything. You can get Pokemon types, which is an query which will be triggered from client to fetch the data. I think if you'll be getting this one when I run the graphical server, right? When I make an actual query, then you'll be getting what it is. What's the query?
So if you could remember from the previous slide, right? So we have this get movies, right? So that is something we are defining here. So we are basically exposing these query types to the client.
Okay. So and also like I'll be using a library called Apollo. Apollo is a library that enables fast development of GraphQL in Node.js. Okay, so Apollo has both server and client. For now, we will see the client server part. Uh, Apollo has a complete package for the graphical implementation. To not to say simply. So let me start. What I'll do. Able to see my screen? Anyone? So what I'll do, I have this folder. I will create a directory named Pokemon Apollo server. Okay, into this folder, right? I will insert an empty Node.js project. So it by default it will take these things. So now I have implemented an empty Node.js project. Just as a package.json. So if you see here, right, I have only inserted an empty project. So in this one, right, I'm gonna add two packages. One is will be Apollo server, another will be GraphQL. Apollo server, as I said earlier, right, it has complete package to implement the GraphQL server, and the GraphQL will be using to parse the query which is sent from client. The query which is sending, right, as we see in the earlier thing, right, he was sending a GraphQL query, right, in GitHub query. That query parsing will be done based using this particular GraphQL package. It takes some time to install. So now our package got installed. Now what I'm going to do, I'm going to create a new file called app.js. So this is where our most of the code lies. So what I'm going to do, like I'm going to import Apollo server from this particular package. Once I got the Apollo server, right, I'm going to start the server by using a server.listen. Once server is started, right, we can in the console we can say that console.log graphical server is started. So we didn't give anything. We just gave only the we just creating a server and it's trying to start the server. Not run the application, right? We can run it. What it says. So what it says that Apollo server requires either an existing schema module or a type definitions. Type definition is the type definition we have created here. Okay. So you can go here. We can create a variable called type def. Okay. So the schema which we created, right, we can give it here. So it's the type definition. So you can pass the type definition by creating a server here. So if I run the server, right, now the server will get started. So GQL is the graphical query language. So this is one of the way to give the input. So now initially, like before this particular thing, right, how we have to give the graphical, these particular things are there, right? How to create the graphical will give us JavaScript object for each of this particular type. So suppose the graphical dot string you have to use. So that is but it was a bit difficult to developers to write, and the code was much bigger. So what they did, right, they made a wrapper on top of it where you can give this particular string. These strings will be converted into a graphical schema object and it will be executed.
So basically whatever inside GQL is a string, it's nothing more, and like because of the intelligence or the package that you have installed, it's showing it as a type, etc. So what GQL does is like it parses the string inside and basically exports the type definition.
Any doubt till now? Just created a server. Yeah. Yes, Express. We can also by default takes 4000. If we can also specify a port. Okay. Okay. So what's the benefit of Apollo, right? If you use Apollo, right, you can integrate any kind of Node.js HTTP framework. We can integrate with Express. We can integrate with Guava, Happy. By default, it gives the packages. If you see the like it's very easy to integrate with other frameworks. So by default, it works with the same port. Just the URL will be changing. So I didn't get it. Yeah, we can also process as a file. We can read, but we can store in some file, and then we can read the file, and then we can pass the value here. Yeah, this is also executable. So now we define the type, and we're gonna start the server. So if I go here, right, where is that? So by default, graphical server gives us this particular UI, as you asked, right? So it comes by default. We can disable it on production. In development mode, we can use it. In production, we can disable it, this UI. So here, right, if you can see the documentation, if you can you able to see the docs thing here? So you can see the documentation here. Documentation, what it does, right? It has this particular server has two queries where one fetches the Pokemon types, one fetches the Pokemon. If I click here, right, here this is the thing it's returning here. So it is easy, like person who consume data, right? It is very easy to understand. And also if it comes to the Pokemons, right? Here we have to specify Pokemon type should be passed in this particular thing, and it then returns the data here. That's how documentation comes by default here. So if we come to schema, right? Here also we can see the schema which I have written, right? The Pokemon schema, Pokemon base, everything will be comes by default with the graphical. So what I'm gonna do, right? I'm gonna write a query. So I'm gonna fetch a Pokemon types. So if I try to hit this one, right? So what the error it comes? Yeah, I can change thing. Okay. So if I try to query the Pokemon types, right? What it's saying? Find Pokemon types of type must have selection of subfields. Did you mean Pokemon types? So we cannot query entire fields in graphical. Just if you have 10 fields, right? You have to specify 10 fields to fetch. So if I see here, right? If I in this one, I should specify a field here. We should not specify blank. We should not leave it as blank. At least you specify at least one field. Either you specify all the fields or just you specify what are the fields you needed. You can't fetch the entire you can't fetch the entire thing in a wildcard way. Okay. I didn't get it. Okay. That will come. That's why it's null. So since right, we just return the type schema, but didn't say we didn't say graphical to where to fetch it from. Just say this is the type definition. That's why it's giving null. So okay, let us write some solver for it. That's where the resolver comes in the picture. So right, we have defined the type definition. Now what we're gonna do? We're gonna define the resolvers. Okay, resolver will be the same structure as schema. Here, right, we can specify a query. If you see the here, right, query. and also inside query, right? You have Pokemon types, that will be on key, and then it will have a function. Whatever written the function, right, will be return to the graphical. So if I return something here, right, let us say example, return id colon some id comma name some okay. So if I save this one, right, okay, I didn't specify the resolver in the, so we have to pass the resolver to the graphical server to configure. Fetching the name. So the resolver you're writing, right, it should match the exact schema of the types of here, right, I have a query, inside query I have the Pokemon types, right? Okay.
So
I have specified here, right? So I have specified here. So actually in actually how actually, right?
so it basically resolves using the name.
Name. So
So
actually you can specify
at the
it like this.
top, you have specified the query, and the query will be having this particular name. And again, like inside the resolvers object, you have this query property. Inside that, you will be defining that particular property name. So based on the property name match, it Apollo servers matches those, and yeah.
So we have set up a resolver also. Okay. Now we need to connect to our Pokemon DB and to fetch this information, right? So what I will do, I have this already have this Pokemon DB. I just drag and drop here. So I have the Pokemon DB. So in the Pokemon DB, I think Pokemon DB as an API, okay, third-party API that exposes some APIs and all. So here, right, I have exposed some APIs like get Pokemon types. That's an API call. That's an API. Think as an API. It gives us a type list of types. We're gonna consume and we're gonna send in the resolver. So here, right, now we return the resolver here. If we say resolver, right, I'm returning just this data, right? What gonna we do, right? We're gonna import the get Pokemon types. This function will return the list of Pokemon types, which is stored in this particular file. So if I go here, right, I can directly give this function here. Okay. Now if I restart the server, right, if I try to query, I will get the all the data. So here, right, if I don't want the ID, right, I can in query I can say I don't want the ID, just want the name. Just gives us a name. This particular thing will be handled by graphical by out of box. Just need to specify the type definition. So just we need to define the resolver. The graphical will be able to understand whatever data it gives. It able to give the proper data. So now we define the Pokemon types. Next thing we want to do, right? Next thing now we have listed this particular written API for listing these Pokemon types. Now we have to fetch based on the Pokemon type ID. We have to fetch these Pokemons. We have defined our schema Pokemon type ID colon. I specify one number. If I specify this one, right, I should get the Pokemon names as of now. If I run this query, right, it will be null because we didn't create a resolver yet. Okay, let us try creating a resolver for it. So how we define for similar same as before, right? So we have to, as in the query, right, we have to define the Pokemons here. So by default this function gets a few parameters. So it gets a parameter called parent and it gets a parameter called augments. So So args will be whatever we send here, right? It will be coming as args here. Okay, you wanna see? So if I run this one, right? You see here, right? Whatever I'm sending here, it comes as args here. So with this argument, right, I can fetch the Pokemons, right? So similarly, in this function, this particular DB, I have already have one function called get Pokemon get Pokemons. Okay. So if you pass some ID, right, it will return the if you pass a Pokemon type ID, it will return the list of Pokemons. So I will use this function here. Return args dot Pokemon type ID. Okay. So what graphically enables us, right? In the schema, what you have defined, this particular argument should be mandatory. If I didn't pass this argument, right, it fails. So if I didn't pass this argument, right, it should be failing. It's not clicking. Okay. Repeat it. So it is okay. I have to pass it as argument. Here I have to pass it as argument. Okay, sorry. So if I pass a Pokemon type 1, right? 1, if you see our database, right? 1 will be like normal type. You can see a Pokemon type of called 4. If I pass the fourth one, right? It gives us Bulbasaur. Bulbasaur is a poison type. So it gives us information. Here, right? If you see this particular thing, right? I think it should work. It should throw an error. I think request is not going here. If you see the red mark, right? This ID is still not allowing us to make the query. But by default, it will throw a 400 response error where it's stating that you didn't pass this particular parameter, mandatory parameter.
So I think it may be a glitch with this playground, because in
Yeah.
GitHub GraphQL we saw a few errors when we didn't pass, right? Yeah.
So yeah, right. We can fetch. Suppose we have types, right? When this one we have types, right? Types will have a list of what are types, right? If I call these types, right? It says types we have in the schema, right? What we have defined, the schema, right? We have defined types as object of Pokemon type. So then also we should specify the name here. Then only it will work. Which one? This won't work. This won't work. This will throw an error here. So if I give a type.
So any collection, even if it is two levels deep or 3 levels deep, you need to specify the fields that you need.
Okay.
By default, it won't return all the fields. That is where it doesn't work actually.
So if you see here, right, we actually have one problem here. So here, right, if you see the types, right, we have types specified as object here. If you see the data, right, if you see the Pokemon data, right, it's an integer. So we have to write a custom resolver for this particular field alone. So if we have, suppose we have the object, in the object for particular attribute, we want to write a custom resolver. That also we can do. For that, right, what we need to do here, right, we need to create a Pokemon object in the resolver. Inside this one, for that field, right, you can write a function. what that function does, right? Will accept the parent object. Okay, what it does, it should return, this function should return an array of Pokemon types. So what it does, right? From parent will be this particular one object. From the parent, get the types. Okay, dot map of, for each type, right? Just get the Pokemon type information. So if I go here, right, I have another function called get Pokemon type by ID. If I pass that ID, right, I get the Pokemon type ID. So what I'll do, here I will have a ID only. So if I pass the ID, right, I'll be getting the Pokemon type ID information. So now I define the, it's kind of overriding an existing field, kind of overriding existing fields. That's what we done here. From this server, right, again, so 19, I have to specify a name here. You see here, right, I'm able to get the, in the data level it's an integer, but when it comes to from when it's written from the graphical, right, it's an object here. That's how we do that's how we do custom solver for a field level.
So basically what happens is here is like when you compare it with the API, there are two method calls. Basically you will be having two API calls. So that is where we need to be very careful when we're doing all those fetches. So it may be also a database query call. Right now the sample here is just a function call, but it can be an API call, and we can have multiple API calls down the level. So it will exactly give the data that you need after collating all the results or responses from the multiple API calls.
So this particular example will help us to avoiding calling nested API calls in a REST API. So this one will send a single request, which in turn will get this particular information, this information also. Got it? Okay. So now we have seen object type, and then getting a solver for object type, and overriding a custom attribute, those things. So what if, like in this one, right, I haven't.
So any question regarding the custom attribute? So if you didn't understand anything, can let us know.
Yeah.
Okay.
For Pokemon type, the ID was kind of integer.
Mm-hmm.
For Pokemon, it's string. So
So
ID attribute you're saying, right? This facing about ID attribute, right? So ID attribute will accept both the thing. So you can give an integer or a string. You can accept anything. It's like just specifying that for that particular object, it's an ID.
so internally, even if the types are different, say int or string, the server in turn converts it to the particular string maybe and do a comparison. So internally that conversion happens.
Just for documentation purpose to understand. So suppose in database, what will say is we just say the primary key. So you say the primary key, right? Similarly, in this one, we are saying that it has an ID. Okay, now, right, let us take another scenario where you want a field called image in the Pokemon thing. So the image field is not there in the list itself, in the particular data itself. So what can we do? We can achieve this also with resolver. Resolver, right? Simply you can go there where you specify the Pokemon object type. You can create a attribute called image where it will have some function, and it will return some image URL like http // some URL will be there. So we'll come to this one if we have time, right? So this will return some URL. So what can I do? I can just restore the server. If I go here, right, if I fetch for call for image thing, to return out this particular custom newly created URL. Earlier thing, we just overrided the existing field. Here, like I created a new field which gives us some other data. So in this case, right, image can be like given as like parent dot id. So if you give it like this, right, so what happens? So if I run this one, right, try to specify that. So if you see here, right, the for each image, the parent id will be different. Okay, any doubt? Till now? Okay. So, what's the favorite part of a Pokemon? Huh? Evolution, and then if you are a trainer, what you'll do? If you are going to gym, you have to get the Pokemon, right? So, capturing a Pokemon. So, we're gonna write a mutation where if you give a Pokemon ID, it will capture the Pokemon. That's a normal case, right? So that's like we're gonna implement a mutation with the Pokemon, with the graphical. So if I go here, right? So similarly for mutation, type mutation. So still again mutation is a root type. So by default comes with graphical. So in the mutation, right, we're gonna specify a function called capture Pokemon. Okay, which will get the Pokemon ID as input, which is mandatory. So once I got the Pokemon information, right, I should return something. I will return that Pokemon information itself. This is the schema I have written here. Okay, let me start the server. Okay, that's it. I forgot to say one thing. See here you can pass multiple query also. We can fetch Pokemon types also here. So with the graphical, right, we can pass multiple queries in a single thing. So if I hit this one, right, both the thing will be executed and you can fetch the result. In this case, right, we have the Pokemon types and Pokemons also. So that's one of the thing. Any doubt in this one? This will be primarily used in most of the mobile application. When mobile application, right? Suppose we have a screen, we have just 5 components. How to fetch the 5 components information in a single API call? It will be giving like this. Now comes to mutation. So mutation, you can specify a mutation key here, and then capture Pokemon, which will get the Pokemon ID. Will give us Pokemon 001. Bulbasaur. Once I capture the Pokemon, right, it should return the Pokemon name and the Pokemon ID. That's information we should return. So if we run this one, right, it will be null. Why? The solver didn't enter the solver. So we'll go there and then we'll create a type called mutation. Okay. So we'll type a function called capture Pokemon. So this is the same name we were given here. So it's also same thing. We get the parent which I want to use. So I'm gonna using aux. So now I got the aux. So what I plan, like, instead of storing those those information in the DB, right, I'm gonna create a temporary variable called in memory captured Pokemons. Okay, so it will be empty array. So whenever I run this call this function, right, I will add the ID in this particular array just for demo purpose. So what I will do, in memory Pokemons dot push of aux dot Pokemon ID. So aux which comes from the particular thing. So before like you can add it, and then also once I added this one, right, I'll be returning I should return a Pokemon object. So I have a function where it will get the Pokemon by ID. If I pass ID, it will return the Pokemon object. That's the function I'm using here. So once I capture the Pokemon, right, so I will pass the same Pokemon ID. I will return it here. So now I got the now I return the resolver for the mutation function called the capture Pokemon. I go here. So we have captured Bulbasaur. Okay. So if anyone from audience want to write query which gets the captured Pokemon. I want to give a try. Okay. So audience also can help him. So first thing, what we want to do here? Now we want to get the list of captured Pokemons. Define the query. So you can keep it as captured Pokemons. Oh. Captured Pokemons. It will not accept anything. So what will return?
Pokemons.
List of Pokemon. Pokemon. Okay. So now we have defined this type definition. Now what we'll do? We'll next time what we'll do? The solver. So Pokemon. Capture Pokemons. Empty object function. Return. So already we have a function. We just do a map in memory dot map. That's the in memory will have only ID. So we have to do a mapping, and then we get the ID. Error function. Get Pokemon by ID. Yeah, of ID. Okay. Can you run this one? Can you stop the server again? Okay. So this will have this particular thing. We have to specify a query. Just remove the connotation. Query capture Pokemon. It didn't came out. Is it coming right? Yeah, we'll see the code. We'll check the code.
Should be saved.
Yeah. Query should be caps.
Oh, okay, sorry.
No, wait, right?
Which one caps?
Check Pokemon. It's not coming. Capture something.
Captured Pokemons. And it's the same here in the below.
Yeah,
It's the same. Yeah, it is.
the same thing. Check. Did we save properly and refreshed? So that's a problem. We didn't save properly and refreshed. We'll try it again. Capture Pokemons.
Yes.
Empty object name. So non tick comma. Okay. Yeah. So now if we run, it will be empty because our memory got clear. So if you go back to history, right? I can do a mutation again. So in this one, you have they will have the mutation thing also. So go back to here, right? I will capture the Pokemon. Now what I will do? I will go back and I will try to get the captured Pokemons. I'll get the Bulbasaur. Okay. So there's another interesting case. So
any questions, anyone, or?
Can we write mutations and query in a single record?
no. Okay. So that's another thing. So we have seen query mutation. What's another thing? Anyone remember? Subscriptions. Okay. So why Facebook needs subscription as a thing? So like you're going for a trip and you got a lot of good pics posting in Facebook, and then suddenly your friends are giving a lot of comments and then likes. So it pops up without refreshing, right? In real time, right? So that happens through WebSockets. So with the graphical, right? They made that implementation very easier. So we'll see how it is. In our case, right? Let me see, like whenever I capture a Pokemon, right? If I have a subscriber who knows what Pokemon got captured. So if I have a subscriber, right? They made that implementation very easier. So we'll see how it is. In our case, right? Let me see, like whenever I capture a Pokemon, right? If I have a subscriber who knows what Pokemon got captured. So what Pokemon got captured. Okay. So now to create a subscription, right? We need a module called PubSub from GraphQL. You have to PubSub. You have to install the PubSub module. Once you install the PubSub module, right? So whenever a Pokemon got captured, we should notify the Pokemon, right? So before that, we should define the first of all we should define the schema here, right? Similarly, we have to define a type called subscription. It's a root type from root type of GraphQL, where it has a function called captured Pokemon. It is named as captured Pokemon. Whatever Pokemon captured will be notified here. So it does not have anything, just return the Pokemon, it gives us a Pokemon object. So now we have got this Pokemon thing, kind of subscription. We have set up the schema subscription. Now what we will do? First of all, we have to specify. First of all we have to notify, right? So what I will do? Initially I created the module. Initially I have imported a PubSub module, right? I am using particular PubSub module. Now to from mutation, what I'm going to do? Like I'm gonna publish with the key as captured Pokemon. It can be any key. Captured Pokemon. I will be, what I will do, I will have it as a another variable. So I will pass this data here and here also. So whenever sorry. So here, right, what we are doing, we are updating a data and then we are notifying that the data has been updated and then returning data. So now we define the mutation. So now, right, whoever subscribes to this particular key, right, will get the data. That's how subscription works in backend. So here, right, I'm gonna create a new subscription. So key subscription will be same key. So again, it will have a key called captured Pokemon. In this one, right, we should have another. It will have another object called subscribe. So it will have in turn, it will have the function. So PubSub dot async iterator is one of the flag. So it accepts. Forgot the syntax. So it accepts this particular key. So PubSub module will iterate through. I will keep on iterating, and whenever it gets this particular key, right, it will return the data. Let me see the syntax along. Like I forgot the syntax. Right. So I have to return this value. That's it. So I have to just return this value. So here, right, whenever you give this value, right, I have to give the value in names of.
Can you change the key?
Which one?
Captured Pokemon.
Where is it?
Pull down, right? async iterator inside, yeah.
Okay, sorry. Okay. So here, right, we have to specify invitation, right? We have specified the Pokemon here, right? We should specify the same key. Then only it will be able to understand the. For this one, it has given this particular value. So in this event, right, what we are doing, we're publishing an key which specifies that the captured Pokemon is this one. So the subscription function which has the same key, we understand I got this value and then I have this particular key. So then I can fetch this value and then show in UI. That's how it works. So we'll see an example how it we'll see in the UI. A subscription, right? Again, we have a subscription key where it will give the capture Pokemon. We want to fetch name and then image of the particular Pokemon. Okay. We run this server, right? It will be listening. The WebSocket has been started. I can add a new tab. I can capture the Bulbasaur again. So Bulbasaur has been captured here. Automatically value is coming here. So in our case, right, UI opens the WebSocket. Suppose if you want to implement this particular thing, right, in the GraphQL, have to create a separate WebSocket server, and then from the graphical client, so Apollo client has its own library where we consume this particular event, and then you can fetch data. Any doubt in subscription? Server means like okay, okay. So to answer the question, right? If you have multiple server, right, the same code will be deployed in all the server, right? Exactly. So if you dispatch this particular event, right, there's high possibility the same server will get this particular value. Same server will get this value and will be data will be given to the user. Yeah. Yeah. Mm. So okay, this particular logic is there, right? These two logic is there, right? That happens in the server level. This particular the publish and the subscribe thing happens at the this level. So server level. So this particular function will return a data Pokemon data whenever it is captured. So now to do it right, whoever the UI client is there, right, the React or Vue, right, will subscribe to this function initially, opens the WebSocket. So suppose we have 10 UI is there, right? So 10 connection will be 10 UI WebSocket connection will be created to the server. So whichever server passes the data, right? So in this case, right, this particular code will be executed in a single server. So whichever WebSocket will come to the server will be able to push the data to the client.
So basically, the publish and subscription pattern, right? So we can have multiple clients subscribe to a single publisher. So you mean like the server that is implementing this, and as well as the WebSocket that is running the client. Yeah, sure.
Yeah, sure. So to answer the question, right, the PubSub thing is there in this one, right? Will not be happening. Will not share across different servers. Will not be shared across different servers. The WebSocket connection which is made between the server and the UI, right? That will have that can be in different servers. So that's a subscription, right? Now we have our for our application, right? For application we have this API and this one, and can capture Pokemon also. So we don't have time to see the UI. So I have done the UI part also. We can see how it works in UI level. So I have written this particular thing in React, which can be using graphical client, which just gives the graphical subscription, like graphical consumption thing very easily. So you can consume graphical APIs very easily using Apollo client. All these mutation subscriptions can be done easily. So let me start the server. Let me start the. So we have two servers, like UI server and UI and backend, separate thing. So server is running up. Oh, so I didn't start the image. 1 second. So if you see here, right? So we have a Pokemon application where it fetches from the API and which is able to get all these things. So if we inspect the data in element, right? Element. So if I see the network tab, I should be able to see a graphical call, which sends the request in a post parameter. So if you see go down, right, send the response in the post parameter, and the server gives back the result. That's how we have implemented this one. So any doubt?
Any questions? Any doubts?
Okay, so test the graphical, right? We have a tool called graphical karate. That's an open source thing. Design like open source tool, like communities are actively developing those things. So you can refer to that graphical karate. Mm. So here, right, if the one thing is the graphical karate, other thing, right, you can use normal language specific test tools to test the resolver functions. Mm. So when you come to testing, right, you're doing a UI testing or API testing? API testing. So API testing, right? So first of all, if you want to do API testing, you need a documentation, right? It comes by default with the graphical. So graphical does not graphical says that whatever specified in the particular documentation will be coming, right? So you can write all possible test cases with that particular documentation itself. So in order to help you write that test cases, right, there's a tool called graphical karate, which helps us to. Like just to summarize what is Apollo here. So, this is where the graphical fits the best suit. So here, right, we have a backend server where we have REST APIs, microservices, databases, these kind of things were there. So these things will have its own languages, its own way of exposing data in HTTP or JSON in the JSON format or XML format, or some database. Some may express the database directly, like Redis. So we have this kind of database, and then we have these kind of UIs. Suppose we want to develop something, we want to consume this information, all these things, right? So graphical will be better suit. So if you use Apollo, right, Apollo will help us to develop much faster in graphical thing. So that's it for now.
So GraphQL doesn't need Apollo, but Apollo helps to make your development faster. So can explore more on the tool chains around GraphQL. Yeah.
So We like to spend 5 minutes of time to give a feedback. Mock mesh. So you're saying validation part, right? So there is a way. So we have seen the scalar types, right? Scalar types. Like that. Suppose if you wanna get a type called email, still you can do the email type. Suppose the particular field is not an email format, right? You can specify the email custom messages there. But one of the restriction, right? If you call a graphical API, it will always sends two things, 200 or 400. 400 means the query is wrong. So you have to specify. You have to tweak the response in such a way, right? You send the error message in the response itself. The response will be 200, and that message will be 400. That's how we will be implementing in. So okay, when it comes to load balance, right? Still, this application is a web application which runs in HTTP server, typical server. So we have to deploy in a number of instances. On top of it, we have to put a load balancer. That's how it works in the same way. Suppose if we want to access something in a common, right? We have to specify in a common. Suppose like a session or catch, right? We have to specify as a common for all the instances. That's how it works.
So people at the back, like if you are not able to scan, maybe you go near, can scan.
Thank you, guys. Thank you.
Hello. Uh, Thank you, folks. Thank you very much for coming. We really appreciate the time and effort you took to come here. And please share about this event to your friends and colleagues. Thank you very much.